So far, we've talked a lot, and I mean a lot, about processing big data that might be sitting on your Hadoop cluster already or sitting in a database already, but we haven't really talked about how that data gets in there in the first place. So now we're going to talk about streaming, and this is the process of actually publishing data from some source like web logs or sensor data or something like that, and actually getting that in a scalable manner published into your cluster where you can actually do some processing on it. Maybe that processing is also done in real time. So this is called streaming, and we're going to talk about in the next section just how you go about publishing that data from your data sources into your cluster in real time so that you can then process it. Let's dive right in. The first technology we're going to talk about for streaming data into your cluster is going to be called Kafka. This is a publish-subscribed messaging system. So what is streaming anyway? What are we talking about? Well, we've been talking a lot so far about processing data on your cluster using tools like Hive and Pig and Spark, but we're assuming that your data is already on your cluster somewhere. It had to come from somewhere though, right? Like it didn't just magically get onto your HDFS file system or it didn't magically get into a database. Sometimes you want to process new data as it's coming in, and you don't want to deal with having to load it manually all the time in these big chunks, right? So that's where streaming comes in. With streaming technologies such as Kafka, you can actually process new data as it's generated into your cluster. Maybe you're going to save it into HDFS, maybe you'll save it into HBase or some other database, or maybe you'll actually process it in real time as it comes in. We can do all of that with streaming. So there are many applications of this. For example, you might be monitoring customer behavior data coming from the logs on your web servers. You might want to be transforming those logs into databases, into more structured forms. You might have sensor data coming in from some big Internet of Things deployment, right? Or you might be dealing with stock trades coming in real time. Who knows? It could be anything. But usually when we're talking about big data, there's a big flow of it coming in all the time. And you want to be dealing with it as it comes instead of storing it up and dealing with it in batches. So streaming lets you publish that data in real time to your cluster, and you can even process it as it comes in if you want. So there are two different problems to this whole scenario of streaming. One is how to get the data from your data sources into your cluster. So you might have a very widely distributed cluster of web servers or sensors or what have you, and you need some mechanism for being able to publish those to your cluster in some scalable and reliable manner. And then the second problem is what you do with it once it gets there. So we're going to focus in this section just on that first problem. How do I actually publish data from my data sources into my cluster at scale? So Kafka is one popular solution for this. It's not just a Hadoop thing. It's a more general purpose publish-subscribe messaging system. So what does that mean? Well, you can set up a cluster of Kafka servers, and their entire job is just to store all incoming messages from publishers, which might be a bunch of web servers or a bunch of sensors or who knows, for some period of time. And as it comes in, it will store them up and publish them to anyone who wants to consume them. Now, these messages are associated with something called a topic, and that represents a specific stream. So, for example, you might have a topic of web logs from a given application or a topic of sensor data from a given system, right? Consumers basically subscribe to one or more topics, and they will receive data as it's published. And the good thing is that Kafka, because it stores it, your consumers can catch up from where they last left off. So it will maintain the point where each consumer left off and allow them to just pick up whenever they want to. So it can publish data in real time to your consumers, but if your consumer goes offline or just wants to catch up from some point in the past, it can do that too. So it's very flexible in how it can manage these sorts of things. That's one thing that Kafka is especially good at that other systems aren't so good at, managing multiple consumers that might be at different points in the same stream, and it can do that very efficiently. And again, Kafka is not just for Hadoop. You can use this for any sort of application outside of Hadoop as well that requires some sort of publish-subscribe mechanism that is scalable and reliable. And I can tell you from firsthand experience that is actually a very, very hard problem, especially in the face of an unreliable network. Anyway, architecturally, this is basically my retooling of an image from the Kafka website, but you can think of a Kafka cluster as being at the center of this entire world of streaming data here, so that might represent many processes running on many servers that are distributing out your Kafka storage and Kafka processing. Now, producers are the things we talked about that are generating the data. So these might be individual apps that might be listening for new log lines. They might be listening for new sensor data, but somehow they are applications that have been written to communicate with both the thing that's generating your data and to Kafka. So these apps are responsible for pushing data into your Kafka cluster. Now, on the other end, you can have consumers that just receive that data as it comes out. So as producers publish messages to topics, these consumer apps might also be might be subscribing to those topics and receiving that data as it comes in. So these consumer apps also link in the Kafka libraries to be able to read that data as well and process it in some way. So for example, you might have a Spark streaming app that is actually configured to talk to a specific topic on a specific Kafka cluster that receives data in real time from these apps up here. Now, usually, there are going to be existing apps you can use off the shelf. You don't always have to write them from scratch. So even though it says app, that doesn't necessarily mean you're going to be developing an app in order to use Kafka. Often there are ones you can just use off the shelf, and Kafka even comes with some built in that might serve your purposes. So don't be too scared about that. You can also have connectors in Kafka, where they're just plug-in modules for various databases that will automatically either publish new rows in a database as messages on a topic to Kafka, or can receive new messages on a topic from Kafka. So you can set up a database to automatically publish changes into Kafka, or to automatically receive changes that come into Kafka as new rows in a database. So you can see that can be pretty powerful stuff. You can monitor an existing database, throw that into a Kafka topic, and you can have some other application that's listening for changes to that database and processing it as they come in. Or you might have some producer of data that's publishing data into Kafka that you want to store more persistently, and you can have a database just connected to Kafka that's listening for all that new data and automatically saving that data to new rows in some database table. Also, one last thing you can do with Kafka is what's called stream processors. And what these can do is transform data as it comes in. So your producer, for example, might be producing maybe unstructured raw web log lines out of a web server. You might have some stream processor that listens for new log lines from that log data, extracts the information you care about it in a more succinct and structured format, and then republishes that on a new topic back into Kafka. So think about how you might set this up. Let's say you have a bunch of producers that just listen for new logs on a web server, every access that your web server gets over your entire fleet of web servers for some giant website. You could have a stream processor that processes those log entries in real time, extracts the information you care about, which might just be a few fields, and then republishes that on a new topic, which could go to a database connector to be stored more persistently. So that's an example of the power of Kafka's architecture. You can make these pretty fancy systems that are very scalable, very fast, that can transform data and store it and do whatever you want with it really as it comes in. How does Kafka itself scale? Well, like we said, Kafka can be spread out on a cluster of its own, so you definitely don't want a single point of failure with Kafka. You can actually have multiple servers, each running multiple processes, and those will distribute the storage of the data on your topics and the processing of all the publishers and subscribers connected to Kafka, or consumers and producers in Kafka terminology. You can also distribute the consumers themselves. So let's say you have a consumer group that is all a bunch of consumer servers that are all subscribed to the same consumer group. So these guys are configured to have the same consumer group name. In this situation, when Kafka publishes data to that consumer group that's subscribed to a given topic, it will distribute the processing throughout that entire group. So in this situation, you might have 4 servers that are set up to process data on some given topic, and Kafka will automatically distribute messages throughout that entire cluster of computers there. So as new data comes in, it might send one message to C4 and another message to C6 and the next message to C3. And that way you can actually scale out the processing, the consumption of that data. You can also set things up so that each consumer has its own group, and in that case, each individual group will get its own copy of each message. So that's what this image here is trying to show. I just lifted that from the Kafka website. But the point is, you can set things up to distribute the processing of data as it comes into a consumer group, or you can actually replicate that data to as many groups as you want. It's up to you. So with that background, let's play around for a bit. Let's kick off the Kafka service on our Hortonworks sandbox. First thing we're going to do is set up a topic and just using some command line tools, publish some data into it and watch it get consumed by another consumer that's also running from a command line. And then as a more interesting example, we're going to set up a file connector. And what it's going to do is actually listen for changes to a given text file on our sandbox and publish that through Kafka and actually write that out to another file somewhere else. And we can also listen to that from another consumer as well. So let's see if Kafka really works and get more familiar with it and get our hands dirty. Let's dive in.